Hey everybody, Dr. A here, and in this video we're going to be exploring another example of how to analyze vector components, and in this particular example we're going to be using a vector triangle. Now we've had some other videos and examples where we used a combination of a vector parallelogram and or a vector triangle. In this example we're just going to go straight for the triangle, okay? So let's go ahead and take a look at the given information. Here we're being told that if the resultant of two force vectors has a magnitude of 1.3 kips, and remember that's 1,300 pounds because one kip is 1,000 pounds, and is directed along the positive x-axis, we're being asked to determine the magnitudes of F1 and F2 and the angle theta so that the magnitude of F2 is a minimum. So let's take a look at the figure we have. Here we have this eye bolt that's subjected to two applied forces. F1, which is at a 30-degree angle measured from the positive x-axis, and F2, which is at an angle theta measured also from the positive x-axis, but in quadrant 4. Okay, so how do we go about analyzing this? Well, again, we need to remember a couple of things. First, we know the resultant, right? We know that we have this resultant force here along the positive x-axis, and we know that its magnitude is 1.3 kips. We also know that we want F2 to be minimized, okay? So how do we accomplish that? Well, let's go ahead and write solution here. And we're going to start by saying sketch the force triangle, okay? So let's go ahead and sketch this. And what I'm going to do is I'm going to start by drawing F1. So here's F1. And I'm going to go ahead and draw the resultant force. I'm going to use a different color here. So I know that resultant force. I know what it is. It's 1.3 kips, right? And I'm going to go ahead and use this kind of law of transmissibility where I can translate this vector F2 over, okay? And remember, the idea behind that is kind of goes hand in hand with the parallelogram rule when dealing with vectors. So basically, I take this F2 and I attach its tail to the head of vector F1, okay? And I place it just like that, okay? So this is going to be F2. Now, the thing to keep in mind is first, we know one of these angles for sure. We know that this is a 30-degree angle, okay? But what do we not know for sure? We don't know theta, right? There's actually three unknowns, theta, F1, and F2. So my next question to us is, where is theta in this force triangle? Where is it? Is it here? Is that theta? No. This is theta over here. So I can indicate this is theta. How do I know that? Well, again, if I put a horizontal help line here, then I know that this is theta up here. And so that would mean that theta will be the angle between the head of F2 and the head of the resultant force. And remember, I don't know theta, okay? So what does that really mean? Well, if I were to, say, project F1 out some, okay? I'm projecting F1's line of action out, all right? What can really happen is F2 could be oriented in, based on theta, it could be oriented here, or here, or here, okay? Or really infinitely many orientations. It could even be oriented out here if I were to project FR out, okay? Again, remember, both F2 and theta are unknowns, right? So the length of F2 and its orientation are both not known. But what we were told was that F2, the magnitude of F2 should be a minimum. So how do we accomplish that? Well, we're going to make a note here. Okay, we're going to say, we put a little star here. We're going to say for magnitude F2 to be a minimum, F2 must be perpendicular to F1. Okay, so really what should happen is we should have F2 oriented right here. Okay, let me scroll back down. Okay, really F2 should be oriented here in purple, all right? Which means that drawing F2 kind of at this arbitrary angle here, we need to adjust that, okay? So I'm gonna adjust this and put that arrowhead here. And again, F2 should be perpendicular to F1, which means that I'm gonna have a right triangle right here, a right angle right here, and this angle is theta, okay? So how do I know this? How do I know that F2, again, this is F2 in purple, how do I know that it's got to be perpendicular to F1 by this sentence over here? Well, again, if F2 is going to be the smallest possible value it can be, well, that means that at a 90-degree angle with F1, that's where F2 will be the shortest possible length it could be. Think about it. If F2 were shooting out over here, okay, then this value of F2 would be a greater value compared to if it's at 90 degrees with respect to F1. Same thing from my original figure. If I stretched F2 out over here and this 90-degree angle all of a sudden got larger than 90 degrees, F2 would be larger. So we can look at this graphically and say, hey, F2, for it to be the smallest possible value it could be, it's got to be at 90 degrees here. So what does that mean for this little interior angle? We're going to say thus theta will be 60 degrees. How do I know that? Well, again, this is 90 degrees, this is 30 degrees, and so the remaining third angle has to be 60 degrees, okay? Now, knowing that, what can I do? I can now use either right triangle trigonometry or the law of sines to compute my unknowns, okay? So I'm going to go ahead and make a note here. I'm going to say now we can use right triangle trig to get the magnitude of F1 and the magnitude of F2. So how do we do that? Well, we can just look at that triangle and say the sine of 30 degrees is equal to opposite over hypotenuse. In this case, so the opposite side is magnitude of F2. Hypotenuse is 1.3 kips. And so we'll get the magnitude of F2 to be 0.65 kips. And that's one of my answers. Similarly, I'm going to say cosine of that 30-degree angle is equal to adjacent over hypotenuse, where the adjacent side is magnitude of F1 and the hypotenuse is still 1.3 kips. So the magnitude of F1 is going to be equal to 1.13 kips. And again, we're looking at this as a right triangle where the hypotenuse is the 1.3 kips, that resultant force. Okay, so that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for more content like this. Thanks for watching.